In this video, we're going to look at the physical property of density. Let's start by defining density. Density is the measure of how much mass an object has per unit volume. It's a fundamental property of matter that describes how closely packed the particles are within a specific space. The closer the particles are together, the higher the density. To calculate density, we use the equation that's shown on the screen, where density is equal to mass over volume. You should have come across mass and volume already, so remember that mass has the symbol m and is measured in kilograms. Volume has the symbol capital V and is measured in meters cubed. Density is a new quantity that we're learning about today that has the symbol rho from the Greek alphabet and is measured in kilograms per cubic meter. If we were to write density in symbol form, the symbol form would look like this, that rho is equal to lowercase m over capital V. So we're now going to calculate the density of an object when provided with its mass and volume. So on the screen now I've got a worked example. Hopefully you've got this printed in front of you. If not, you can always work on paper, but please work through this example with me so you know how to do it in the future. So here the question says, a block of metal has a mass of 20,000 kilograms and a volume of 4 meters cubed. And it asks you to find out the density of the block. So the first thing we do is we highlight what we know in the question. So we can see here that we've got that the mass is 20,000 kilograms and the volume is 4 meters cubed. So I'm just going to make a note of those two things. So the mass M is 20,000 kilograms and the volume V is equal to 4 meters cubed. I then use the equation, the density rho is equal to my mass over my volume. Then I need to put the numbers in. So density rho is equal to 20,000 over 4. Remember in science you can always use a calculator, so you don't need to do that in your head. And if you put that into your calculator, you get the answer to be 5,000 kilograms per meter cubed. So you can just run through now and show you where you get the marks for this question. So the first mark is for substituting the numbers in. So having that density is equal to 20,000 over 4 is 1 mark. You get the next mark for getting the correct answer, which is 5,000. And your final mark is for the correct units, which is kilograms per meter cubed. Can you please mark your work now? I'd like you to have some practice now at being able to calculate the density of an object when provided with its mass and volume. So on screen now are 3 questions that I'd like you to complete. And after you've completed them, I'll go through the answers with you. So what I'd like you to do now is pause the video and complete these 3 questions. Hopefully that was enough time for you to complete those questions. I'm going to run through the answers with you now. So as always, we're going to go through and highlight what we know first. So the first thing to point down is for question 1 that our mass is 24 kilograms. Also for question 1, we've got a volume of 0.00125 meters cubed. We're then going to write down the equation. So here, our density rho is equal to mass over volume. I'm just going to put those numbers in. So you get 24 over 0.00125. We can now put those numbers into our calculator and we can then find an answer. So substituting those numbers into our calculator, we get an answer of 19,200, and that will be in kilograms per meter cubed. So to work out the marks for this question, we get 1 mark here for substituting our numbers in, so 24 over 0.00125. The next mark is for the correct answer of 19,200, and the final mark is for the units kilograms per meter cubed. Let's go through the same process then for question 2. So in this case we've got a mass of 353 kilograms and we have a volume of 0.491. I would usually write those values down so that I had them to refer to, but I haven't got very much space here. So I'm just going to write the equation then, that rho is equal to mass over volume, and then I'm going to put those numbers in. So rho here is equal to, the mass is 353 over 0.491. again, what we're going to do now is we're going to substitute those numbers into the calculator. So if you calculate 353 divided by 0.491, you get an answer of 718.94, and then some more decimals there. Now, to get the right answer here, I need to round up. Because I've got a 718.9, I go to round up to 719, and that will give me my answer to 3 significant figures, which is what I've got here in the question. You can see 0.491 is to 3 significant figures, and 353 is also to 3 significant figures. So 719 is my answer. I'm going to then give the units, which are kilograms per metre cubed. Okay, again, running through the answers to show you how you get the marks. We get 1 mark here for substituting the numbers to 353 over 0.491. 1 mark for an answer which is 719. You can have a mark here for any answer that rounds up to 719. And then 1 mark for the correct unit, which is kilograms per metre cubed. So can you give yourself a score out of 3 for that question, please? Okay, we're going to move on to question 3. Just to highlight something on question 3, that's worthwhile is it tells you to give your answer in grams per centimetre cubed. So that means we don't have to convert anything for this question. We can use the numbers that were given in the question. So again, I'm going to go through and highlight it. What I've got a mass of 7 grams. So mass is 7 grams here. And I've got a volume of 1.4 centimetres cubed. Because I want my answer in grams per centimetre cubed, I don't need to do any conversions. So then go through the process of writing out the equation, mass over volume, and then going to put my numbers in. So I'm going to have 7 over 1.4. I can put that into my calculator, and I get an answer of 5 there. I then want to give the units, which are grams per centimetre cubed. For this question, I only get 2 marks because I've been given the units. So I get a mark for 7 over 1.4, which is the correct substitutions. I get a mark for the correct answer, which is 5. Can you give yourself an overall score then out of 8 for this slide, please? So now we're going to look at how to calculate the mass of an object this time when provided with its density and volume. So on the screen now is a worked example. Again, I'd like you to work through this with me to make sure you know how to do these in the future. We're going to try and keep following the same routines that we have done before, so we get used to how you should answer this if you're in the exam. So first thing to do is go through and highlight what we know. So I've got volume of 224 metres cubed, so I'm just going to write that down up here. So V is equal to 224 metres cubed. I've also been given that the density of water, which is my rho, is equal to 1,000 kilograms per metres cubed. Okay. What I then need to do is write out the equation. So I've got that. I'm going to use symbol form again. Hopefully you feel confident with this. So I'm going to have that rho is equal to, I'm trying to find the mass, and that's going to be divided by my volume. So you can see that I've put those in the same colours as what I've written the numbers in. So I'm just going to substitute those numbers in now. So rather than writing rho, I'm going to write 1,000. And that then is going to equal mass over 224. Okay, so now I need to rearrange the equation in order to get mass. Okay, I'm going to go over to this side here. So what I need to do is I've got the 224 on the bottom, so that currently it's mass divided by 224. To move mass to the other side, I'm going to have to times through. So I'm going to get 1,000. If I had paper, I would work underneath my working, but I'm having to go to this side of the slide here. And because I've got a divide here, I'm going to have times through. So I've got 1,000 times 224. That's going to equal my mass. Again, I can just use a calculator now to work out the correct answer. Putting that into a calculator, you get the answer of 224,000 is equal to my mass. So that means that mass is equal to 224,000 kilograms. Let's work through the answers here. So the first step is for substituting the numbers into the equation. Because this is a rearrangement calculation, if it's early on the exam paper, you'd often get a mark here for the correct rearrangement. You get a mark for the correct answer and a mark for the unit. So can you give yourself a score out of 4 there, please? So I would now like you to practice calculating the mass of an object when provided with its density and volume. On the screen now there's 3 questions, questions 4 to 6. I'd like you to complete these yourself, and then I'll go through the answers with you. So if you could pause the video now and complete those questions, please. Okay, so hopefully you've had enough time there to answer the questions. What I'm going to do is I'm going to go run through question 4 with you. So the first thing to do is find out what we need to calculate. So we're finding the mass here, highlighted in yellow, in grams. So the thing that we need to do first is just go through and highlight what we know. So we've got density is 1.74 grams per centimetre cubed. That's okay because it's in grams, I don't need to change the units there. And we've got a volume of 0.1 centimetres cubed. Again, nothing needs changing there because it's in centimetres cubed and the units match between the density and the volume. So I'm now going to write out my equation, that rho is equal to mass over volume, and I'll substitute the numbers in. So I get 1.74 equals mass over 0.1. So I need to then rearrange the equation. Remember, I've got a divide here, so I'm going to take that through by times in. So I get 1.74 times 0.1 equals my mass. And my mass will equal 0.174 grams. Okay, just to show you how you get the marks, we get 1 mark here for substituting the numbers incorrectly. So 1.74 equals mass over 0.1. The next mark for rearranging correctly to get that 1.74 times 0.1 is equal to my mass. 1 mark for getting the correct answer, which is 0.174, and then 1 mark for the unit, which is grams. So can you give yourself a score out of 4 there, please? For question 5, again, we want to find the mass in grams. Just going through and highlighting what we know. Again, we've got density here is equal to 7.14 grams per centimetre cubed, and our volume being 13 centimetres cubed. Going through the same process, we know that's okay because both the volumes in centimetres cubed and the mass is already in grams, so we don't need to change anything. So I'm just going to write the equation out again. So rho, density is mass over volume. Put the numbers in. So I get 7.14 equals mass over 13. Rearranging, I've got a divide here, so I need to take the divide through by times in. So 7.14 times 13 is equal to my mass, which means that my mass is equal to, and we could put that into our calculator. So we want to do 7.14 times 13 there. So here we get an answer of 92.82 on our calculator. I actually round that up to 3 significant figures because that's what I was given the question. I get an answer of 92.8. And remembering our units, we want it to be in grams. Running through here to get the marks. We get a mark for substituted incorrectly, so 7.14 is m over 13, or mass over 13. Then rearranging, 7.14 times 13 is equal to our mass. The correct answer of 92.8, and then finally the units. So can you give yourself a score out of 4 for question 5, please? Okay, moving on to question 6, we go through the same again, where we highlight what we know and work out the correct answer. So the first thing to do is, this time, we are working out the mass in kilograms. What we know in the question is we've got density is 1,440 kilograms per metre cubed, and we've got volume of 0.005 metres cubed. So again, the units match, we don't need to change anything here. Write the equation out, so rho is equal to mass over volume. Put in the numbers. So here we're going to get 1,440 is equal to mass over 0.05. We're then going to put the, we've got a divide here, so we need to take that to the other side by times in. So we get 1,440 times 0.05, If we put that into our calculator, we will get an answer for our mass. And that will, when you put that into your calculator, you get an answer of 7.2 kilograms. So again, we're going to run through the marking here. We get a mark in this case for putting the numbers in. So 1,440 equals mass over 0.05. We get an answer then for rearranging to get 1,440 times 0.005 is our mass. An answer for the correct, a mark for the correct answer of 7.2, and then a mark for our units, which is kilograms. So we're now going to look at how to calculate the volume of an object when provided with its mass and density. I've got a worked example question on the screen again. So again, please work through this with me as I go through it so you see how to do it in the future. As we've done before, we're going to start by highlighting what we know. So we've got here density is equal to 11,000 kilograms per meter cubed. And we've then got that mass is 25 kilograms. So I'm just going to put these up here. That mass is 25 kg. And density rho is equal to 11,000. Okay, and it wants us to calculate the size of the block. Remember, it's 11,000 kilograms per meter cubed. Okay, so here we want to calculate the size of the block, which is the volume. So the next step, as always, is the same. So we're going to do that rho is equal to m over v. We're going to substitute our numbers in. So we get the 11,000 is going to equal our 25 over v. Now this one takes a little bit more rearranging. So the first step is to realise that we've got to take the v to the other side. So we're going to have 11,000 is currently a divide by v here. So we're going to have to times by v here to get that. The next step then is that we want to get rid of the 11,000. So we're currently timesing by 11,000. So to get to the other side, we need to do the opposite. So we're going to have to divide it by 11,000. So we get that v is equal to 25 over 11,000. Now you don't necessarily have to take that many steps to get to this point. You could have just jumped straight there. That's okay. The next step, as always, is to put that into your calculator. So if you put that into your calculator, you get an answer of 0.00227, and they're recurring. Now remember that for physics, I can't leave that number like that. I need to round it up. In the question, I've really only got two significant figures, so I'm going to round it to two significant figures here. So I'm going to get an answer equal to 0.0023, and my volume will be meters cubed. Okay. What I'd like to do now is just quickly run through how you get the marks for this question. So you get a mark for correctly substituting the numbers into the equation, a mark for the correct rearrangement, a mark for the correct answer, and a mark for the correct unit. So can you give yourself a score out of 4, please, for this question? So I would now like you to practice calculating the volume of an object when provided with its mass and density. To do that, there's some questions on the screen here, questions 7, 8, and 9. I'd like you to complete those. Whilst you're completing them, please pause the video, and then once you've finished, unpause it, and I'll go through the answers with you. So please pause the video now. Okay, so hopefully you've had enough time to answer the questions here. I'm going to run through the answers with you now, so please mark your work as we go through them. So the first thing to do is highlight what we're trying to find out. So I'm trying to get the volume here in centimetres cubed. Knowing what I know, so I've got density is equal to 13.5 grams per centimetre cubed. So rho is equal to 13.5 grams per centimetre cubed. And my mass, however, is in kilograms at 2.7. So I want to change my mass or my density so they're both in kilograms or grams. I think here it might be easier just to go into grams. So to change 2.7 kilograms into grams, I need to times by 1,000. So mass is going to be 2.7 times 1,000. Because that's how many grams there are in a kilogram. And that means that my mass now is equal to 2,700 grams. Okay, I would get a mark for a conversion here if this was in the exam. So getting 2,700 grams would be a mark. Also, you could have done 13.5 divided by 1,000 to get your answer there, which would have also been acceptable of 0.0135 grams per centimetre cubed. What I now need to do is put the numbers into the equation, like we've done before. So rho is equal to mass over volume. So here I get 13.5 is equal to 2,700 over V. V then would equal 2,700 over 13.5. That's going to give me an answer if I put the numbers into a calculator. And it comes out actually to equal 200 centimetres cubed. So again, in terms of marks here, you're going to get a mark for putting the numbers into the equation correctly at this point. So 13.5 is 2,700 over V. Rearranging to get 2,700 over 13.5 is equal to our volume will be the next mark. A mark for the correct answer and a mark for the correct unit. Remember, you also get a mark for the correct rearrangement. So can you give yourself a score out of 5 for this question, please? So we'll now look at question 8, where we've got to do the calculation again. So again, same process as before. We're going to go through and underline what we know. So we've got that the density of air is 1.2 kilograms meters cubed. And we've got that the mass of the air is 3 kilograms. So we write the equation, which is a density equals mass over volume. And we put the numbers in. So here we're going to have that 1.2 is equal to 3 over our volume. Rearranging the equation again, so times the v to the other side, so you get 1.2 times v, and then divide by 1.2. So we get that v is equal to 3 over 1.2. And if you put that number into your calculator, you come out with an answer of 2.5. That's going to be meters cubed. Running through how to get the marks for this again. We get a mark for the substitution of the numbers incorrectly. We get a mark for the correct rearrangement. We get a mark for the correct answer and a mark for the unit. So can you give question 8 a score out of 4, please? So moving back on again to question 9, we're going to go through the same process as we've done before. We'll highlight what we know. So here, this time, we've got a density of 916.7 kilograms per meters cubed, and we have a mass of 10 grams. Now in this case, the kilograms and grams don't match up, so we're going to have to do a conversion. Okay, I'm going to convert the mass from grams into kilograms here. So to do that, there are 1,000 grams in a kilogram. So I want to convert into kilograms, so I'm going to do the mass, I'm going to do it on this side here. Mass is going to equal 10 over 1,000. That's going to equal 0.01 kg. So I now have them in the correct units. I'm then going to go through the same process I've done before. I'm going to add in here my equation. So rho is equal to mass over volume. Substitute the numbers in. I get 916.7 equals 0.01 over volume. And then we're going to rearrange so that we get volume is equal to 0.01 over 916.7. And if we put that into a calculator, we'll get an answer that will be 1.09086423 times 10 to the negative 5. As we've got 4 significant figures for our density, we're going to have to round our numbers up to 4 significant figures. So I'm just going to make some room on the slide so that I can write the answer down. So rounding up, we're going to end up with, to 4 significant figures, we're going to get an answer to be 1.091. I can leave it in standard form and do times 10 to the negative 5, and that will be meters cubed. Okay, so I'm just going to go through and give you where we get the answers. So first of all, we've got 1 mark for converting our units. So the 0.01 itself is a mark, so I'll convert the units there. We get another mark for substituting the numbers into the equation. We get another mark for rearranging the equation correctly. We get a final mark for the correct answer. And then finally, the last mark here is going to be for getting the correct unit of meters cubed. So can you give yourself a score out of 5 marks there, please, for question 9? So now I'd like you to apply your knowledge of density to predict whether an object will sink or float in a particular fluid. you can see we've got data for solids on this side, and we've got data for liquids on that side. I'd like you to use that data there and your knowledge of density to determine the outcome for each of the questions below, and you've got 4 questions there. So you're going to use the density of these different liquids over here, and densities of the solids over there, and decide whether or not they'll be able to float or sink in water. So remember that if you want a solid to float on a liquid, the solid must have a lower density than the liquid. If you would like a solid to sink in a liquid, then the solid must have a higher density than the liquid. So I'd like you to use that information there to answer these questions. You might want to pause the video now so you can answer the questions. Okay, so hopefully you've now had enough time to answer these questions here. What I'm going to do in a moment is I'm just going to go on to the next slide and go through the answers with you. Okay, so here are the answers. So the first question said, what is the only solid in the list that will float on water? So the first thing to do is look over here, and we can see that water has a density of 1,000 kilograms per meters cubed. So we need to have a solid with a density lower than 1,000 in order for it to float. And you can see that all of these numbers are greater than 1,000. The only one that's lower is lithium, which is why lithium is the only solid in the list that will float on water. Question 2 says, explain what will happen if you pour olive oil into a glass of water and why. So again, we'll look at olive oil. So 920 kilograms per meters cubed here compared to water, which is 1,000. So olive oil has a lower density than water, so therefore the oil will float on top of the water. And remember, that's because it's got a lower density. Okay, moving on to question 3. It says lead is quite a dense metal. Explain why a lead block will float on mercury. So if you come here and look at lead. So lead has a density of 11,340, but mercury has a higher density than that of 13,550 kilograms per meters cubed. Because mercury has a density of 13,550 compared to lead, which has a lower density, then lead will float on top of the mercury liquid. The last question here is explain why the design of ships such as the Queen Elizabeth aircraft carrier is able to float. So in this case, what we want to do is we want to explain why any boat will float really, and that is because although the boat is large and heavy, its density is low because it's got lots of empty space inside the boat. So by having empty space inside the boat means that you've got areas where there's like free space, which means that the overall mass per unit volume is less, therefore it's got a lower density, which means it can then float. So hopefully that's run through all those questions there. I should leave them on for a few seconds just so you can make sure you've got them all correct. And the final thing then is to say thank you very much for listening. I hope you've enjoyed the video, and I look forward to speaking to you next time. Thank you and goodbye.